In math, there are many different calculations used. That is why mathematicians use programs to make their lives easier. One such problem is root approximation. We are 5 errors, and in this video, we are going to discuss our approximation of roots calculator, or ARC. In this video, we are going to discuss 3 methods in obtaining the approximate of a square root. There is the bisection method, the secant method, and the Newton's method. The bisection method is an approximation method to find the roots of the given equation by repeatedly dividing the interval. This method will divide the interval until the resulting interval is found, which is extremely small.
First, we define a function for bisection method with 2 parameters, which are the interval and the epsilon equals to 0.001. And then we initialize the variable of n equals to 1. And then we have a condition: if epsilon is less than or equals to 0, then we set the epsilon equals to 0.1. And then we have two another variables here, which are the an and the bn equals the interval. So for instance, we have interval of 1 and 2. So this value will be distributed to an and bn respectively. We have another 3 important variables here. This will serve as an initial values for the iteration table. The first one is the Cn is equals to parenthesis an plus bn divided by 2. And then Sn is equals to bn minus Cn, which has the condition if Sn is less than or if Sn is less than or equals to 0, then it will accept as the root and then stop the loop. In this part of the code, while the condition is true, the loop will continue till it's find the root.
Newton's method for solving equations is another numerical method for solving an equation f of x is equal to 0. It is based on the geometry of a curve using the tangent lines to a curve. As such, it requires calculus, in particular differentiation. Roughly, the idea of Newton's method is as follows. We seek a solution to f of x is equal to 0.
Another function, which is the Newton's method. And next, we will initialize the variable, which is n is equals to 0. And we have here another function, which is f of x is equal to mat_po with the parameter x of n and 6 minus x of n minus 1. And then a derivative x of p, f of x of p is equals to 6 times mat_po with the parameter x of n and 5 minus 1. And an iterate table which are n, x of n, f of x, and 0.
We use while loop as a loop in our Newton's method and the iteration formula. This loop will not stop if the root is not found. So let me discuss you the two functions, which is the overflow error and the zero division error. The overflow error happens when the computation goes to infinity, and the zero division error occur only when the computation of program encounters zero division. The program will stop computing, it will show the computers. It will show where the computer stopped. The return function will show you the table of the Newton's method. And here's a demo of the Newton's method that we create.
In numerical analysis, the secant method is a root-finding algorithm that uses a succession of roots of secant lines to better approximate a root of a function f. The secant method can be thought of as a finite difference approximation of Newton's method.
So for the secant method, it is similar with Newton's method. The only difference is that there's two initial guesses for secant method. Unlike in Newton's method, there's only one. And as you can see, the code is very similar. It's very similar, and it is the same structure with the other methods where the while loop will continue to compute for the root until the root is found.
And those are the three methods that we use for our ARC program: the bisection, the Newtons, and the secant methods. Again, we are the 5 errors: Seth Valenciano, Jhon Pablo, Pauline Carag, Cyrus Jarod Layugan, and Janine Aira Ribao. Thank you for watching.